Welcome everyone. I'm going to talk about replacing module builds. First I'm going to talk about the history of Perl build systems and the current situation. And then I'm going to talk about the future and stuff I've been doing and to some extent some other people. It all started with MakeMaker. About MakeMaker MakeMaker was released along with Perl 5. It's a fairly old piece of code. And after around the year 2003, Shorn, the maintainer of MakeMaker, posted a well-known webpage called MakeMaker is Doomed. You should look it up, it's quite funny. But yeah, he was quite right. MakeMaker has a lot of serious issues. It's convoluted, it's scruffy, it's hard to extend, and it has an external dependency. Convoluted. This thing is... It's not quite working, guys. It's giving too much. I'll figure it out. The problem with MakeMaker, one of the main problems with MakeMaker is that it's essentially written in 3 languages at the same time: Shell, Make, and Perl. And while generally we all know Perl, most people do not. Well, a lot of people know Shell, and a few people know Make. This wouldn't have been so bad if Shell and Make were actually portable concepts, but they're not. Shells, for example, it's not just like, on Unix it's all Bourne shell, that's the easy part. But then comes along DMS, or DOS, or Windows, or Mac OS. Those tend to be rather different. In case of Make, even GNU Make and BSD Make are sufficiently different that you can't write an if statement that works on both. Even if all of that was not a problem, they work with command sets that are platform specific, so essentially that means they're different everywhere, which means everything gets a lot more complicated. And lastly, most of the things it runs aren't logically external commands. A lot of the time what happens is we have a Perl program writing a make file containing pieces of shell that actually go back into Perl. Which really would have been so much easier if you could just call a Perl script, Perl function instead of a Perl script or a Perl one-liner. There's a lot of accidental complexity there. MakeMaker is crafty. Last week I found this comment in the source code. This subroutine is not supported anymore since about October 1994. As some of you may remember, that's when Perl 5 was released. That stuff never got removed. We still have some fairly old operating system that in theory, I think 5.8 supports all of those in practice. No one's really using that anymore. Yeah, extending MakeMaker is also quite an exercise in making it difficult. The main way to extend MakeMaker is just define some functions in this magical main namespace called my, which doesn't scale very well. That wouldn't be so bad if there was an actual API behind it, but in a lot of cases it's just calling something else, getting a piece of string that's a makefile, and then either adding to it if you're lucky, or manipulating it if you're not lucky. There are not a lot of people who actually successfully do this. They do exist. And the last problem, when you're actually there, you're stuck with the problem of having to generate code that works on all the various platforms. So, again, on Windows or on Unix or on VMS, you actually have to write out very different code to the makefile, which means you actually have to have an understanding of all of those systems, which generally speaking no one does. The last problem is that MakeMaker very much depends on Make. This used to be a serious issue. In my opinion, this is the lesser issue nowadays because distributions like Strawberry Pro just ship Make along. So now pretty much everyone has Make who's actually having a Pro. Yeah. So then came along module builds. A module build was started around in 2001 by Ken Williams, who was like, screw this stuff. Breathing. Screw this stuff. I'm going to make something that's pure Pro, that's actually maintainable, that people could actually extend because they know Perl and not because they have to know two other languages. And this was a pretty brilliant idea. It also introduced some other ideas that nowadays are taken for granted, but really were not back then. For example, the meta files. Module build was very early, fairly strong on metadata. It added non-runtime dependencies like build and test dependencies. It added install base, which was a more sane way of installing your modules to a separate directory. And it started the build PL convention. Essentially, the way module build works, CPAN clients have an understanding of how this stuff works, which becomes important more later when you're writing something else that works similar. However, module build had a rather rocky start. Module build was declared production ready when it really was not. And this made a lot of people very unhappy because suddenly their system was broken and they couldn't install stuff anymore, and a lot of misery. It wasn't included until about 5 years ago in core, which means people first had to install module build by hand before they could continue installing their modules, which was generally fairly annoying, and if you don't know about the problem, then it can be kind of confusing too. And lastly, there was the whole install base and prefix debate. What happened was that Ken decided this old way is completely crazy. He was completely right. So he came up with a new way that was superior in every way except not being backwards compatible. Which turns out to upset a lot of people if you install a module and then it doesn't work because it's not installed to the right location. This was eventually resolved when install base support was added to MakeMaker and prefix support was added to module build, and then they could both agree on installing location. If you actually look up like on CPAN ratings about module build, then at least half of the stuff you're seeing is complaining about this thing, even though it's like 6-7 years ago. That's another reason why CPAN ratings tend to be fairly useless. However, module build is doomed too. Yes, this is me. Module build is lacking in dependency graph. It can only be extended by subclassing, and its design is very non-modular. This is a piece of code that's similar to what module build is doing all the time. Do something if the target is older than the dependency. And this works out quite alright in simple cases. However, this is very hard to extend. Because if you want to do something else with the target, you have to make sure the action where this code happens has to be called first. Which means that which means you have to know exactly what happens where. This is not abstracted at all. The other way around is even more problematic. If dependency is generated dynamically, then suddenly you have to make sure that wherever it's generated runs before any possible action that may use the dependency, which essentially means it's impossible to do it sanely. It will break at some point in time. This really screws over module build all the time. Secondly, module build uses subclasses for extendability, which worked out quite alright when all people did was customizing their build. It works. However, this also means that you can't compose two different module build extensions into one builder because of the way inheritance works. That just completely breaks. In theory, you could kind of fix it if you use C3 MRO, but I've never ever actually see someone be insane enough to actually do that. Also, it would kind of be problematic on 5.8. There is a very recent module called Module Build Pluggable that's trying to fix this, but essentially it's really a big hack, and it's really, there's quite a lot of things you can't do because it's only very limited in what it exposes. The last problem is that module build is not modular at all itself. It's absolutely the biggest module I've ever worked on. Like I said, it's like the slide says, it's like more than 5,000 lines of code. It has hundreds and hundreds of modules. It has the 88 accessors that are all read-writes. And yes, that does happen, that stuff gets written to where you're really like, why would anyone else write that ever? And it happens. If you're unlucky, they're not even using the accessor. It's a mess. The internal architecture of module build is a good example of how not to do this. I'm not saying that Maker is a lot better in this regard, but at least this was the second attempt. As some of you may know, like 3-4 months ago, there was an announcement on a discussion and then an announcement on P5P where we basically decided module build is gonna be removed from core. That may sound surprising given that it only entered core in 5.10. But there are a number of reasons for that. The first reason is that module build turned out to be not quite as successful as people had expected it to be. It's now 12 years old and the adoption rate is about 15%, and it's not rising anymore. It's a minority tool, and that is unlikely to change. The second reason is that improvements in the toolchain have made it unnecessary for it to be in core because it can automatically be bootstrapped whenever you need it, which is probably going to be pretty soon if you actually use cPanel at all. And the last reason why it's no longer in core is that core itself doesn't use it, can't really use it. It really doesn't need to be there. Nowadays, we really try to have a small core with the least possible, well, not least possible, but least useful amount of code, of extensions, and leave all of that to cPanel. Then there was module install. Module install got kind of popular when module builds really wasn't. It's an extension around Maker that tries to Maker tends to be fairly unfriendly to the author if you want to do everything properly. So then people came up with module install, which includes itself into the distribution, adds extra functionality. So this way, the end user didn't have to have module installed on his own computer because it was shipped along, and then it worked magically. However, module installs do it too. The internals of module install are absolutely insane. Roughly for this, well, it's a make-maker extension, and it's essentially insane because it's doing all those things you shouldn't do, but there's no other way. Regaxing pieces of makefile and that sort of stuff is often the only way to get stuff done. Even most people who do use to write these extensions are now like, hell no. Secondarily, the including is a time bomb because it freezes the code that's in there. In 5.8, a very, very subtle feature, what I think Perl was broken, deliberately. Previously, after a regular expression and a named operator, you didn't absolutely have to put a space in between the regex and the operator if it didn't look like a flag. So you could do like slash s slash whatever and without a space. And it turned out an old version of module install actually did this, which is completely insane. But because these old versions are shipped in the CPAN distributions, this means that to fix this, all those modules have to be released. And given that this version is like 5, 6, 7 years ago and they haven't seen a release since, they're probably not going to ever see a release again, which means all those distributions are broken. There are some portability issues too, because again, the people who wrote it kind of knew Unix, and at least one of them knew Windows, and then none of them knew VMS. And then all module install distributions don't install VMS, even if the module would otherwise have worked fine. And lastly, it's essentially completely unmaintained nowadays. It used to be maintained by Adam Kennedy. He kind of disappeared, and no one really wants to pick it up again because it's completely batshit insane. So that's the current situation. Oh wait, another one. Another recent development is Distilla, which, how many of you are using it? Fair enough. Which is an authoring overkill. But it works. And it's very fascinating because it managed to achieve one thing that none of the install tools actually ever managed, which is a healthy plugin ecosystem. Different people can use this thing in very different ways, and they're all still using the same tool. The other thing it got absolutely right is separating authoring from installing. The tools I previously mentioned are used by end users, but also by the author to generate distributions, test them, to add various files that are necessary in CPAN distribution. And Diesel decided to split this up entirely, which means that the install tool can be vastly simplified because the authoring is often more complicated part. Yeah. Diesel has a few downsides to it. It's slow. It's oh my god slow. I have a distribution where running like Diesel run true, which essentially is a no-op, takes about 20 seconds if it's hot, if the caches are hot, and about 30 if they're not. It's really that slow. Well, that's a big distribution, but still. Diesel depends on a fairly significant amount of modules, and then pretty much any plugin of any author in practice will double the number of modules. So if you're installing Diesel to hack on someone else's distribution, and then you suddenly installed like 250 distributions just to hack on something. Lastly, its plugin architecture is fairly fragile. Essentially, in the dist.ini, you give it a linear list of plugins, and they're loaded in that order and sort of executed in that order. It's a bit more complicated than that, but the ordering matters. Which means that some plugins have this documentation that says, be sure to run this first or last, or before this and after that. 90% of the time this is not a problem, but when it is, it's really, really annoying. So, I'm finally at the future. I hope I haven't bored you with the past. There have been two developments that have really, really opened up possibilities for better and new install tools. The first of that is the build PL specification. What we did is we took a look at module build and said, what are the important features here? What are the features that any CPAN any CPAN client needs to install this module? And we wrote a specification for that. So that means that we can be implemented. The second important development is configure requires. Configure requires is essentially is an entry in the meta file that says, please install these modules first before trying to do anything else. This means you no longer have a bootstrapping problem where you have to install the build tool by hand before you can actually install the module itself, which means magic happens. The build PL spec is essentially all the commands like Perl build PL, build test, build install, but also arguments like install base and verbose and all those things. It also specifies various configuration items, and lastly, it defines where to install stuff. This was one of those things that, like I said, in the transition between when module build started was really a problem because no one really knew how it was supposed to work. No one. To some extent, no one still knows how it's supposed to work, if you ask me. Configure requires is amazing. It makes all of this possible. It has one downside. It needs a recent toolchain. 5.10.1 was shipped with this feature. On any older Perl, you would need to upgrade your CPAN toolchain. In my opinion, if you really want to use a legacy Perl, that's your own problem. I'll support you, but it's your own problem. So then came along module build tiny. Module build tiny is written as the simplest thing that could possibly work. It's deliberately a convention over configuration tool. And when I say over configuration, I mean there simply is no possibility to configure it at all. It has sensible defaults. If it doesn't suit your needs, you probably need something more complicated anyway. It was started out as just a prototype. Then it started to become useful, and then wait. Never mind. I think my slides are in the wrong order. Okay, for module build, I had to write 3 dependencies that do some essential stuff that unlike Unlike module build, I decided I'm not going to stuff all of this in one module. I'm going to separate these out so that they are reusable when I'm writing the thing that's not just a prototype. The first of that was Actutils helpers. Actutils helpers does stuff you really don't want to know the guts about. You really don't. Split like shell is essentially we have a string. What arguments would the shell make out of that? Which is not that hard on Unix. You don't really want to know about Windows. You don't. I have no idea about Linux actually. Make executable. Another one of those things where, well, I think most people are Unix hackers and they're like, that's just a chmod. On Windows, you have to write a bash file. On VMS, you don't really want to know what it has to do. You don't. And then there's man page file functions because us Unix people like having colons in the man page file name. That turns out not to work on Windows. These are not things you want to re-implement. These are things you want to use and want to forget about. The second is Actutils config, which is probably my simplest module on ZPan because it's just essentially just grabbing the configuration. But this tends to be the glue that ties together everything I write, even though it's otherwise very, very boring. And then there's Actutils install pop, which was one of the most trickiest to get right. Installing to the right location is very, very difficult. In the end, I decided to take the chainsaw, take out a significant piece of module builds, wrap it into one module, and have that. Because that was the only sensible way I could support prefix. I told you, install base is superior than prefix. It has a very simple reason. Prefix uses about 26 configuration variables plus an install time parameter, 27 on VMS. I'm not sure if there are 5 people in the world who are understanding it. I'm not even sure if there's anyone who really truly understands it. This is one of those things where essentially this was defined as we do whatever MakeMaker 6.30 was doing, and otherwise it's not defined at all. We just can't. Yeah. Module build tiny, essentially, there are 4 actions in build PL. The first is the configuration stage. Essentially, it's doing just this. You're writing a tiny build script, and you're saving your arguments, and you're saving my maker. This is really all you have to, a build tool has to do at this stage. Just compare the later stages. This is really it. The build stage, on the other hand, is the real meat of any install tool. This is also the part where module build tiny shows that it's tiny and kind of sucky, because it does the simplest thing it could possibly do. It does it right. If you want anything more complicated, do something else. Essentially, the only things you have to do are copy over your modules and scripts, fix up the scripts, because OS dependent, whatever. Make man pages if you're on a suitable platform, or HTML. Well, I could have written HTML too, because that's what module build does in some platforms, like Windows. Except that no one ever managed to write the same toolchain to do this, because just a function in module build that does this is bigger than module build tiny. And then, at first I thought I'm gonna write the easiest possible thing, and then I was like, my old limit was like any feature that takes more than 10 lines to implement, I'm not gonna implement. That's how it ended up tiny. Then I decided, having XS support is worth about 20 lines. It works. But essentially, this is all there is to 98% of all CPAN distributions. If you're not doing anything fancy, then this can cover it. Then there's testing. This is all the testing code I have. This is literally the code in there, and this is feature complete. Because someone else already wrote tab harness, which is brilliant. I'm just passing on parameters to test harness, and it will run the test, it will give me a summary, it will give an error if it went wrong. Probably one of the very few things where module build tiny is actually better than make maker, and module build actually gives an error in colors. I really like that because too much blah blah. I just want to know if it passed or not. And then there's install. Again, this is all the code there is. Installing the module doesn't take more code because the difficult parts are already taken care of. This has been made trivial. Yes, module build tiny works. At the start of this year, there were 3 modules using it, all written, 4 including itself, all written by me. Then Miyagawa happened. Miyagawa just basically came up on IRC and was like, gee, is this stuff production ready? And I said, well, I think so. Of course it wasn't. But having Miyagawa use your module means that if anything is broken, you're going to get bug reports at an astounding rate. So 4 months and about 15 releases later, it was production ready. So yes, that's all his fault. And it's quite fastly growing. It's still behind the module build and module install each have about 3,000 modules, so I have a long way to go. But I might get there. One of the other things that makes module build tiny works is that I've delegated all the authoring to Diesel. I have a love-hate relationship with Diesel, but writing the plugin for Diesel to support module build tiny, the first version was about 25 lines of code, and it worked. It worked, and I've made some improvements, but there were no bugs in there. It really was that easy. That's really one of the brilliant things about Diesel. It was trivial for me to add the authoring side. Yes. However, module build tiny is not really the future. It solves one of the 3 problems that I listed, the modularity. It completely gets that right. But it's not an extensible tool. It was never meant to be an extensible tool. It will never be an extensible tool. However, I've proven quite successfully that writing a module build replacement is not that hard. Module build tiny is about 100 lines of code. That's all it takes to write an XS supporting build tool. But I went on. The next step was XUtils Builder. Build tools for pure Perl are not that interesting a deal because there's a fairly limited, there's a limitation to the stuff you can do. One of the weaknesses of the current tool chain is that we don't really know that much about how do I compile stuff. We have like XUtil C Builder, which knows exactly what it needs for a Pro XS extension, and pretty much nothing more. It can't do executables portably, it can't do libraries portably, it can't do a lot of things portably. Linux tends to work through it. So yeah, I wrote this general purpose compiling and linking library. I have to hurry a bit, I think. And the core idea of it was I want to support any possible backend. In module build, for example, I would want to execute immediately whatever commands I've generated. But in MakeMaker, I would want to serialize this to a bunch of commands that I can write to the make file. But by using an abstraction around the actions that I'm doing, I can actually support all use cases quite easily. The second thing I did is that because it embeds all the meta information, not just whatever it does, but also the target and dependencies, it's trivial to plug this into any build tool. I wrote a MakeMaker plugin for this that was about 20-25 lines, and that could convert all these action objects into MakeMaker. Then I wrote Build Simple. Build Simple is essentially a make replacement, the simplest make replacement I could think of. It's a simple build tool that has subs called sub callbacks as actions. And it works quite okay. However, this is not really the thing for the future either. This is again a prototype. Yes, I like prototypes. The real thing was build graph. The difference between the two is that build graph can actually serialize the entire build plan into JSON, which means you have a structure you can actually manipulate sanely if you want to, which is very difficult in module builds. Well, possible but difficult in MakeMaker. Yeah, this opens up a lot of possibilities for more complex extensions. And in the end, I started this build. This build is essentially wrapping all of these things I've talked about together. At its core, this build is a build.pl compatible plugin container. It takes build graph. It takes all of the build.pl things that I've implemented in the previously mentioned modules, and basically, like Diesel does, it allows you to add it allows you to have a scalable system for extending distributions. I was planning to have this finished for this presentation as conference-driven development. It kind of isn't. Stuff happens. However, I know why I haven't finished it. Because the limitation I hit into was plugins. Like I said, Diesel gets this wrong. It does the simplest thing possible, and that turns out to be not good enough. I don't quite know how to fix it, because what the problem is, plugin A could depend on plugin B, or it could depend on a plugin of type Z, and there's no easy way to express that. So I've written it. It works already. It's on GitHub. I haven't released it to CPAN because I want to change how this works. And once it's on CPAN, I don't want to break everyone's code. But that doesn't matter anyway, because the real plan of me was not so much to write a module build replacements. The real plan was to make it easier for other people to do it. I don't want one module build replacements. I want all of you to write module build replacements, and most of them will suck, and one of them will not, and then everyone is happy. I don't care if mine sucks, because if you think it sucked, write something better. Here, it's possible. Also, I think something similar is true for Diesel. I hate Diesel. It has the right idea. It has very similar problems to an install tool. We can do this better. It's not as urgent as module build, but we can do, and we should do. Any questions? Yeah?
I realise this isn't exactly the focus of what you want to talk about, but so that module build tiny uses itself.
Yes.
How does that work?
Well, it just has a build PL that says use lib inc. Use lib lib. And then